Welcome to the Vitality Equation, exploring research in health and well-being one paper at a time. Today, we're diving into some fascinating research titled Multimodal Imaging Reveals a Lysosomal Drug Reservoir that Drives Heterogeneous Distribution of PARP Inhibitors. It's a mouthful, but trust me, it's super interesting and has some implications for how we think about health, wellness, and even how medications work.
Yeah, that title definitely screams science. But beneath the jargon, there are some real gems. I mean, PARP inhibitors are used in cancer treatment, right? So understanding how they're actually distributed in the body is pretty crucial.
Exactly. And the whole heterogeneous distribution part, that's what really grabbed my attention. It's not like the drug is evenly spread out, there's variation, which means some cells might be getting more of a dose than others. And that variability, well, that has to impact how effective the treatment is, doesn't it?
Absolutely. It's like you think you're giving a consistent dose, but the body is doing its own thing, deciding where it goes. And this paper shines a light on why that happens. They found that lysosomes, those little organelles in our cells that act like cellular garbage disposals, play a key role in storing these drugs.
Lysosomes as drug reservoirs, that's a game changer. So instead of the drug just floating around freely, it's getting sequestered in these compartments. And that sequestration, that storage, affects how much drug is actually available to do its job on the cancer cells. It's like a delayed release mechanism, but one we didn't fully understand until now.
It makes me think about personalized medicine. If the lysosomes are acting as these little drug depot, and if everyone's lysosomes are different, maybe we need to tailor the dosage or even the timing of drug administration based on an individual's lysosomal function. That's a huge shift from the one-size-fits-all approach.
That's where I immediately went to. This resonates deeply with my focus on lifestyle interventions. If we can optimize lysosomal function through lifestyle choices, diet, exercise, stress management, could we potentially improve the efficacy of these drugs? Think about it. If we boost the body's own drug delivery system.
Yes, and this is where my brain starts buzzing with cognitive parallels. If the distribution of drugs in the lysosomes can be understood and manipulated, could this possibly mirror a strategy for dealing with dysfunctional thought patterns? Or even enhance the cognitive restructuring process itself?
Hold on, that's a leap. But I see what you're getting at. The lysosomal drug reservoir as a metaphor for how we store and process information, beliefs, interesting. But from a more practical standpoint, I'm wondering how exercise and sleep tie into this. I mean, we know they impact cellular function, so could they be influencing these lysosomal drug reservoirs?
That's it. It's all connected. Think about stress, for example. Chronic stress can wreak havoc on cellular function, including lysosomal activity. So, if someone's undergoing cancer treatment and they're also dealing with chronic stress, could that be impacting how the PARP inhibitor is being distributed and utilized? This is where mindful practices like meditation could potentially play a role.
Naspertesta Sikiro. Lysosomal drug reservoir driving the heterogeneous distribution of PARP inhibitors is fascinating. From a cognitive restructuring perspective, this metaphor suggests we could be inadvertently storing certain thoughts or beliefs in reservoirs that influence our responses and limit our potential for positive change. Just like the drug is sequestered, maybe we're sequestering certain thought patterns.
Okay, I'm back to exercise and sleep. We know that sleep deprivation impairs cellular repair and function, and exercise can improve mitochondrial function, which is closely linked to lysosomal activity. So if someone's not sleeping well or not getting enough exercise, could that be negatively impacting their lysosomal function and, consequently, the effectiveness of the PARP inhibitor? We're not talking about replacing the drug, obviously, but enhancing its effects.
Right? It's about optimizing the body's internal environment. And this paper, by showing the importance of these lysosomal reservoirs, gives us a target. We can say, okay, let's look at lifestyle factors that are known to influence lysosomal function and see if we can improve drug efficacy by addressing those factors. Things like intermittent fasting, certain types of foods, and yes, absolutely, stress reduction through meditation.
It's fascinating to consider the parallel between the cellular processes of targeted drug delivery and the cognitive processes of restructuring thought patterns. This discovery could lead to a new form of CBT, where individuals become more aware of their own internal drug delivery systems and better able to modify their response to negative stimuli.
I'm thinking about the practical application here. Imagine a cancer patient undergoing treatment with a PARP inhibitor. We could design a personalized exercise and sleep program tailored to optimize their lysosomal function. Maybe specific types of aerobic exercise to improve mitochondrial function, combined with sleep hygiene strategies to ensure adequate rest and cellular repair. We could even track biomarkers related to lysosomal activity to monitor the effectiveness of the intervention.
Yes, and we could incorporate mindfulness practices to reduce stress and improve the mind-body connection. Maybe even guided meditations specifically designed to target cellular health and enhance the body's natural healing processes. It's about creating a holistic approach that supports the drug's effectiveness.
The fact that a drug reservoir within lysosomes influences the efficacy of PARP inhibitors suggests a potential for personalized cognitive behavioral therapy (CBT). If different individuals have different lysosomal drug distribution profiles, could this inform tailoring CBT interventions for optimal impact, considering that cognitive responses vary from person to person?
It's all about personalized medicine, right? But not just in terms of genetics or tumor type, but also in terms of lifestyle and individual physiology. This research really underscores the importance of considering the whole person when developing treatment plans.
Exactly. It's not just about the drug, it's about the environment in which the drug is operating. And we have the power to influence that environment through our choices.
How can understanding the heterogeneous distribution of PARP inhibitors through multimodal imaging translate to novel cognitive restructuring techniques? Perhaps this kind of biological process could provide a new lens on how we reframe negative thought patterns or enhance positive associations. This deeper understanding of cellular mechanisms might unlock new therapeutic approaches to cognitive challenges.
And the multimodal imaging part of the study is key too. They use different imaging techniques to visualize where the drug was going and how it was being stored. That's a powerful tool for understanding the complex interplay between drugs, cells, and the body as a whole.
Right. It's not just about seeing that the drug is being, stored in lysosomes, but how much is being stored, where it's being stored, and how quickly it's being released. That level of detail allows us to really fine-tune our interventions.
So it's like mapping the cognitive landscape of the mind, identifying the reservoirs where limiting beliefs are stored, and then developing targeted strategies to restructure those patterns. I'm stretching the analogy, I know, but the core principle of personalized intervention based on individual variability resonates deeply.
Okay, back to reality for a second. This is fascinating research, but it's still relatively early stages. We need more studies to confirm these findings and to investigate the impact of lifestyle interventions on lysosomal drug reservoirs and treatment outcomes. But the potential is definitely there.
Oh, absolutely. This is just the beginning, but it's a very promising beginning. It reinforces the idea that we're not just passive recipients of medical treatment. We can actively participate in our own healing process by making conscious choices that support our body's natural functions.
Indeed, it highlights the interconnectedness of our biology, our psychology, and our lifestyle. And it suggests that by understanding these connections, we can unlock new possibilities for optimizing health and well-being.
Speaking of future research, I'd love to see studies that specifically investigate the impact of different types of exercise on lysosomal function and PARP inhibitor distribution. Like, does high-intensity interval training have a different effect than steady-state cardio? And what about resistance training? It's all uncharted territory.
From my perspective, I want to see research exploring the role of specific meditation techniques on lysosomal function and stress response in cancer patients undergoing treatment. Can we use mindfulness to modulate the cellular environment and improve drug efficacy? That's the question I'm most interested in.
I'm interested in exploring the cognitive parallels further. Maybe using fMRI to map brain activity in individuals undergoing cognitive restructuring, looking for patterns that mirror the drug distribution patterns observed in this study. It's a long shot, but the potential for cross-disciplinary insights is huge.
And we definitely need more longitudinal studies. This was a snapshot in time. We need to see how these factors change over the course of treatment and how they impact long-term outcomes.
Yes, absolutely. And we need to consider the individual variability. Not everyone responds to exercise or meditation in the same way. So personalized interventions guided by biomarkers and individual preferences are key.
It reminds me of the research on honeybees and their surprising behavior changes when parasitized. There was a study showing that parasitized honeybees, they developed a craving for alcohol. I know, it sounds bizarre, but it raises some interesting questions about how external stressors can impact our internal states and lead to potentially unhealthy coping mechanisms.
Wait, honeybees drinking alcohol? That's unexpected. How does that even work?
Well, the theory is that the parasitism creates some kind of stress or imbalance in their system, and they turn to alcohol as a way to self-medicate, to alleviate the discomfort. It's a fascinating example of how even seemingly simple organisms can exhibit complex behavioral responses to environmental challenges.
Wow, If parasitism in honeybees triggers a desire for alcohol, could mindful eating and a balanced lifestyle help reduce our own stress-induced cravings for potentially less beneficial external substances? I mean, maybe meditation could be used to cultivate a mindful awareness of our own internal signals of stress and to help regulate our need for external substances in response.
That's actually a really insightful comparison. It highlights the complex interplay of environmental factors, parasitism, and behavioral responses, alcohol consumption in animals. If I can understand the physiological pathways in bees, I might be able to use exercise and targeted sleep schedules to better manage my stress response.
If parasitization triggers a rewiring of cognitive processes leading to heightened attraction to alcohol, could this be a model for understanding how similar neurochemical processes could affect the cognitive function and decision-making in humans? This connection to potential human pathologies is a significant avenue for research that merits further investigation.
Fascinating. Honeybee behavior, so often overlooked in our focus on human issues, might hold surprising insights into how our own bodies react to stress. If honeybees turn to alcohol, this could reveal a need for a lifestyle approach that focuses on internal harmony instead of external stimulants. If honeybees are experiencing stress from parasitism, could altered sleep patterns be contributing to their increased alcohol consumption? Could exercise, like increased foraging activity, help offset the stress response and potentially decrease the preference for alcohol?
I'm thinking if honeybees are experiencing stress from parasitism, could altered sleep patterns be contributing to their increased alcohol consumption? Could exercise, like increased foraging activity, help offset this stress response and potentially decrease the preference for alcohol? Further research on the specific sleep cycles and exercise patterns of parasitized bees could lead to effective strategies for stress reduction and improved well-being. Maybe sleep deprivation is exacerbating the desire to self-medicate with alcohol in honeybees.
The increased alcohol preference in parasitized honeybees suggests a potential coping mechanism, a way to alter internal states. Could this be studied using fMRI or similar neuroimaging techniques in honeybees, assuming ethically responsible methods were developed to understand the specific patterns of brain activity before and after parasitization?
Right. It underscores the importance of addressing the root cause of stress rather than just trying to mask the symptoms with external substances. And that's where lifestyle interventions can be so powerful. It highlights the complex interplay of environmental factors, parasitism, and behavioral responses, alcohol consumption in animals. This could be a helpful framework for developing better stress management techniques.
This honeybee's response to parasitism reminds me of how stress can influence our own choices, potentially leading to less healthy options. If I can understand the physiological pathways in bees, I might be able to use exercise and sleep to create a similar protective mechanism in myself against unhealthy coping mechanisms.
I find the idea that a parasitic infection could lead to a change in behavior through cognitive restructuring both fascinating and disturbing from a psychological viewpoint. This highlights the delicate balance between internal and external stressors and how they may affect behavior. This finding could contribute valuable information to the development of specific CBT strategies or cognitive therapies to address potentially similar changes in mental processes caused by external stressors or illnesses in humans, even if the mechanisms are different. Examining the cognitive responses in parasitized bees would have profound theoretical implications for these types of treatments, potentially unlocking avenues for cognitive remediation in humans.
Absolutely. It's about cultivating resilience both physically and mentally. If honeybees, creatures with a surprisingly sophisticated understanding of their environment, respond to parasitism by seeking out alcohol, what does that say about how our bodies might be signaling needs beyond the cognitive or physiological? Could there be a deeper subconscious response at play that lifestyle changes like meditation and mindfulness might help us understand and integrate? This honeybee study suggests a potential link between stress parasitism and a craving for something to numb the pain or discomfort. Could meditation, by reducing stress responses, help us avoid those quick fix cravings and develop more sustainable, mindful responses to challenging situations?
It's fascinating how similar the impact of stress can be across species. The bee's response makes me realize the importance of building resilience through both physical and mental exercise routines, not just for physical health, but potentially for managing stress-related cravings or responses.
How might the cognitive processes of a parasitized honeybee differ in their neural pathways, potentially leading to altered alcohol preference? Could this be studied using fMR or similar neuroimaging techniques in honeybees, assuming ethically responsible methods were developed to understand the specific patterns of brain activity before and after parasitization?
Okay, well, that's all the time we have for today. Hopefully, this exploration of lysosomal drug reservoirs and honeybee behavior has sparked some new ways of thinking about health, wellness, and the power of lifestyle choices. Thanks for joining us on the Vitality Equation.
Definitely a fascinating dive into the intersection of cellular biology, cognitive function, and even insect behavior. Until next time, keep exploring, keep questioning, and keep striving for optimal vitality.
And remember, even small changes in your daily routine can have a big impact on your overall well-being. So get some exercise, get some sleep, and be mindful of your choices. We'll see you next time.